Hello everyone. In this video, let us learn about different types of constructors and destructors with respect to object-oriented programming language. We know what is a function and the procedure to write a function and use it in the program. In a previous video, we have also seen how to overload functions, means how to write multiple functions with same name but different set of parameters, which is one of the important features of object-oriented programming. In object-oriented programming, we also have constructors. These are by default assigned for classes by the compiler. So far in the previous programs, we have not written constructor function, but by default, every class will have a constructor function supplied by the compiler. So what does this constructor function do? As the name suggests, it constructs the objects. So when we create an object, this constructor function will get executed and it creates memory for the objects, and it is also used to initialize values for the variables present in the object. And destructors, as the name suggests, it is used to destroy the object when it is no longer required. So a destructor destroys the object. Now let us see how to create a constructor function and how to use it in the program. So basically, what is a constructor function? It is a special member function. So a constructor is a special member function. Member function means function belonging to a class. You cannot write a constructor function which does not belong to a class. It definitely belongs to a class. Therefore, it is called as a member function. So why it is called as a special member function? Because it has same name as the class. So a constructor function has same name as that of the class, and it is used to construct the object. That is, it creates memory for the members of the object and also it initializes some values for the members. It does not have a return type. Therefore, when we are defining a function, we don't have to mention a return value or a return data type for constructor function. It may or may not take parameters. So if it does not take parameters, then it is called as a default constructor function. Now let's see how to create a constructor function. Let us see the syntax of this. So as I told you, there is no return type for this. You have to just mention class name and then just open and closing parenthesis, and then here we will have instructions. Using these instructions, we will be initializing values for a constructor function. So let me write an example for the same. Let us create a complex class. A complex class is a one which has two variables, real and imaginary part. So I will create a complex class called class complex. This is the class. Here under private section, I am going to have two variables. One is real part of the complex number and the other one is the imaginary part of the complex number. Now these two are member variables of this class. Now I will create the public section using public keyword, and constructors are always written in the public section of this class. And here I will write the constructor function. As I told you, it has only class name and there is no return type. So I'll write just the class name. Here I am not writing any parameters, and this is an example for default constructor. Here I am going to give initial values for these variables. So I'll just give real equals to 0 and imaginary also equals to 0. This is a constructor function that I have created for this particular class. Now if I have to display, and here we will have display function, adding, subtracting, all those functions we can write. Now this is called as a default constructor. A default constructor is a one which does not have parameters. Usually it is going to assign the values with the 0. If you want, you can give any other values also. And this constructor function will get called when we are creating an object of this class. We don't have to manually invoke these functions. So it gets invoked, it gets called by the compiler automatically. Okay. So it is called by the compiler automatically when an object of the class is created. So in the previous programs we have only done the declaration. Here we are initializing the value also along with the declaration. So we don't have to manually place a function call, though we can do it that way. We usually don't manually call a function when we are creating an object, that is when we are declaring an object for a given class. Automatically the constructor function gets called. So a constructor without parameters is called as a default constructor. Now we will see different types of constructors, and then we'll write a program for the same. So different types of constructors. First one is a default constructor. So default constructor is the one which has no parameters. Okay, it does not have parameters. Usually we will be declaring the variables inside this constructor function to 0, and when we don't give any constructor for any class, like in the previous programs we have not defined a constructor for the class. If we don't give constructor, then compiler provides a default constructor which allocates memory and which assigns the variables with the default values. And if we want, we can also write definition for it, and see here I have written a default constructor. Since I have written default constructor, compiler will consider this function. If I don't write default constructor, that is without parameters, if I don't give a function like this, then compiler will consider an automatic constructor function. So this is default constructor. Next is parameterized constructor. So parameterized constructor is one which has parameters. It takes some values as parameters, and those values are used to initialize the members of the constructor function. Say for example, in the same previous constructor function, if I write complex, and since I have two integer values, suppose I take int a comma int b as two parameters, then I can initialize the member variables of this class, which is real and imaginary variables, using these parameters. So I'll write real equals to a and imaginary equals to b. So here I am creating a complex object. I am creating an object of this class using some initial values. So it is same as, when we give int x equals to 5, y equals to 10. Here I am creating a variable, at the same time I am also initializing it. Very similar to that, here I am creating an object and at the same time I am initializing value to it. And for this function to invoke this in the main function, when we are creating an object, we have to give values within parameters of the object. So this is how the function definition is written. And in the main function, you will create a complex object as complex C1 3, 5. We are not placing a function call here, but we are creating a complex object, and for this I have given two values. These are the values that will be assumed for this a and b, and those values will be used for assigning values of this real and imaginary. So this is parameterized constructor. When I write parameterized constructor, it does not mean that I have to write two variables itself here. I can write one variable, same variable I can use for assigning values for this. Based on our requirement, we can write different parameters, and such constructors are called parameterized constructor. And the next type of constructor is a copy constructor. It takes reference of an object, of the same class as parameter. This is to create copy of an object. In the previous example, I gave two integer values as parameters for the constructor function. Suppose if I give object reference of the same class as for the constructor, then that is called as copy constructor. Example is, I will create a complex object. I am writing the complex function, and here I am writing the parameter is, let us understand this with an example. Complex, this is the name of the function, constructor function. Parameter is of complex type only, and I'm using ampersand C. Okay, so this is reference of another object. Here real is equal to C dot real and imaginary is equal to C dot imaginary. So this real and imaginary belongs to the object that is being created now, and the C dot real, C dot imaginary belongs to the object that is being passed here. So now what is the use of this is, when I already have a constructor, when I just want to create a copy of that, then instead of passing all the values again, I am going to just pass that object, and using that object an exact copy is created. And to call this function or to invoke this copy constructor, we will have to declare a variable object like this. Say I would have given complex C1 3, 5. So this is the first object that I have created. This is a parameterized constructor which invokes the constructor function that I have given previously as the example. Parameterized constructor function, where A is assigned as 3 and 5 is assigned to B. Now I'll create another object complex C2, and here I will pass C1 as a parameter. I will pass C1 as the parameter, and now what gets created is C2 is going to be a copy of C1. So same 3 and 5 will be assigned for C2 as well. So this is called as copy constructor. These are different types of constructor function, and in the same program you can have multiple constructor functions, and that is called as an overloaded constructor. Now based on what all values I have given, accordingly different constructor functions will be called. So this is about a constructor. And now next is a destructor function. Now destructor function is also a special member function, and it is used to destroy the object which is no longer required. Now how do we decide whether an object is required or not? So whenever we close the scope of the object in which it is created, then the object gets destroyed. So when a main function gets completed, when it completes its execution, all the variables and objects created in that main function will get destroyed. Now we know that anyways the variables will get destroyed when the function execution gets completed, right? Then what is the purpose of destructor function here is, in object oriented programming, suppose we have created objects, and if those objects are accessing some external resources like files or printers or any other network devices, then we will have to close those connections before closing our objects or before destroying the objects. So if necessary, we will have to write some code manually for a destructor function. Now as I told you, just like a default constructor, destructor is automatically supplied by the compiler for each and every class that we create. And suppose we want some additional instructions to be executed when a destructor function is called, or just before destroying an object, suppose we want to execute some more instructions, then we can manually write a destructor function. So this also has same name as that of the class, same name as its class, and it is prefixed with tilde sign. So now if this sign is there, it means it is a destructor function, and destructors cannot be overloaded. So what do you mean by overloading? We can write multiple functions with the same function name and a different set of parameters. And here constructors also, we have written overloaded constructor. We have various forms of writing constructor. Same program can have multiple constructors, that will make it as overloaded constructors. But a destructor cannot be overloaded because it does not take any parameters. It does not require any values. See, we are going to anyways destroy the object, right? It does not take any parameters. It is used to destroy an object. It doesn't require any new values. And when we are destroying, there is no need of parameters intake as well. Since there are no parameters itself, it cannot be overloaded. The basis of overloading itself is parameter distinction, right? The parameters have to be different. Name of the function will be same, but parameters should be different. Here, since parameters are not at all there, we will not be able to overload destructor function. Now let us write one example for the destructor function for the same class, complex class. I will write a destructor function. So I know that this is destructor because we have written a tilde sign here. No parameters to be written inside this. Now we can just write if you have any file references or any other objects that is being held, you can write code to close that. Here I am just writing one output statement to mention object destroyed. And we cannot even see this because these things are executed when it is no longer required. To demonstrate the usage, I will write a block of code and we will see how this will work. And this is executed when an object is no longer required, and we cannot call this. We cannot place a function call for this. Automatically compiler decides when to call. Okay, therefore we will not be able to manually call this function. It is automatically called, but when it will called, we can demonstrate using a program. Now when these constructors and destructors are executed, you know, when a constructor will get executed when an object is created. A destructor will be executed when an object is no longer required. How to know when it is not required anymore? When that scope in which an object is created is getting closed. When that scope is getting closed means that variable is no longer valid. In that situation, it gets destroyed. Now let us see this with an example. The same complex class we will see with an example program. I am creating a program called constructor.cpp. So let us demonstrate constructors and destructors. Now here, as I told you, usually there won't be any output instructions. We will just include some output instructions to understand how it works. We have to write hash include iostream, then using namespace. Here I will create a complex class complex. First I'll create two variables, real and imaginary. Now I'll write public. Here I am going to create constructor functions. Now see, I'll first create a default constructor. Here I'll write real as 0 and imaginary as 0. And also I will write an output statement to denote which one is which constructor function has been executed. Default constructor executed. I've just written one cout instruction just for demonstration purpose, but usually in a constructor function we will not be writing such things. So next I'll write another constructor function which has two parameters, int a comma int b. So this is going to be a parameterized constructor. Here I'll initialize real with a and imaginary with b. Here I'll display parameterized constructor executed. Next I'll write one copy constructor as well, complex. This is complex ampersand c. I'll write real is equal to c dot real and imaginary is equal to c dot imaginary. And here I'll write an output statement which says copy constructor is executed. This is about constructor functions. I will write one function for display, and I'm going to define this function outside the class, and I will write a destructor function as well. Destructor function precedes with tilde sign and it does not take parameters, I'm just, here we don't have any external resources like files to close. So I'm just writing one output statement to denote when it is executed. Destructor executed. So this is our class definition. Now I am yet to define the function display. If you have not seen how to create classes and objects, you can refer one of the previous videos. I'll mention the link to that video in the description. I have explained how to define a function inside and outside the class. So here other functions I have defined it inside the class. Display function I'm going to define it outside the class. When you define a member function outside the class, write the return type, data type. Now you have to define scope of this function. To define scope, we will use class name with scope resolution operator, and then name of the function is given. Here we will display the complex number, and for the complex number I am going to display the real part, and then I'll mention it as plus I. Then display imaginary part, then I'll mention I. Okay, so our display function is ready now. Now I'll write the main function. So first I'll create just one object, complex C1. Okay, complex C1 I'll create. If you have observed, I've not given any parameters, means it is going to invoke the default constructor function, and I will just display complex number is, and I will call the display function C1.display. So we can invoke member functions using an object name and dot operator. So C1 is object created. C1.display will display the objects belonging to C1. Here if you observe, which all functions will get called, default constructor function will get invoked. These two, parameterized and copy constructor, will not be executed. I will demonstrate that as well. And I'm calling display function. Now let me compile this and execute. See, you can see default constructor is executed and complex number is 0 plus 0i. So as I have mentioned here, since there are no parameters, it is going to call this default constructor function, where I am assigning real and imaginary as 0 is assigned to these two variables, and I am displaying default constructor executed, which is coming here in the output screen. Now it goes back to the main function where I have a display function. I am calling this display function. Display function is displaying the value in the form of a complex number, a plus bi format. So 0 plus 0i is getting printed. And I can also see destructor executed, because when the function is no longer required, it executes the destructor function. And the next output that is displayed is destructor executed. This gets executed when this closing bracket is present. That is when the function execution gets completed. All the objects created here will be destroyed. So you can see that destructor function is executed without manually invoking it. Now that is about default constructor. Now I'll create another object, C2. Here I'll pass values 3, 5. Now I am creating two objects. One is complex C1, another one is complex number C2 with parameters. Now this is going to invoke parameterized constructor. You can see the values as well. Complex number 1 is this, and then I am going to just copy paste this one. Complex number 2 is C2.display. I'll save the program and compile. Now see, there are two objects here. When I am closing the function, when the function execution gets over, destructor function gets evoked for both these objects. So destructor executed, that will be displayed twice. So you can see first is default constructor executed. When C1 is created, it is going to call default constructor function, and from that I have got this output. Next C2 3, 5 is there. It is going to call the parameterized constructor, and that output has come from that function. And then I am calling C1.display and C2.display. You can see complex number 1 is 0 plus 0i and complex number 2 is 3 plus 5i. Since I have two objects here, twice the destructor function is executed when this closing bracket is present. Therefore, destructor executed has occurred 2 times. Now I will create the copy constructor as well. So that is C3, in bracket I'll give C2. Okay. So I am going to now display the same thing again. I am creating object C3 using object C2. Now here I will get complex number 3, and here I'll mention C3.display, and basically you're going to get same output for C2 and C3 because C3 is created using object C2. You can see the output now. C1 was a default constructor, C2 was a parameterized constructor, whereas C3 I have passed C2 itself as a parameter, therefore it has invoked automatically copy constructor. And output of the first function, first display function is 0 plus 0i because it was a default constructor, real and imaginary variables was initialized to 0, and the second one was 3 plus 5i, and since this itself is used for defining C3, that is also 3 plus 5i only, and destructor is executed 3 times. So hope this concept is clear. Constructor function is used to create an object. Destructor function is used to destroy an object. Constructor function and destructor function both will have same name as class name, and only destructor function will have this symbol before it. Constructor function will take parameters, therefore it can be overloaded. Which function gets called depends on how many values or what all parameters have been passed when a constructor function is when an object is created, whereas destructor function does not take any parameters, therefore we cannot overload it. These are the differences between constructor and destructor function. If you want notes for this same notes and this program, you can join the Telegram channel. That is link of that is mentioned in the description. The detailed notes and also this source code, this complete source code is present in those channels. You can join them and you can get all the notes and programs. Keep watching for more videos. If you haven't subscribed to the channel, subscribe to the channel and share this video with your friends. See you in the next video. Bye bye.